Welcome friends, welcome back to my YouTube channel. I am Lohit C, pursuing my BE from Sri Venkateshwara College of Engineering at Bengaluru. So now I am in section Devo in third semester now. So today's presentation is on the subject DDCO, Digital Design and Computer Organization is the DDCO, and it has a code of BCS302 and my USN code is 1VE23CA027. So this presentation is going to be on the concept of K-map with its advantages and disadvantages and how the K-map is solid, and these are the concepts which we are going to learn in this presentation. So with the introduction of K-map, so K stands for kernel's map. So kernel's map is a graphical representation used in simplifying the Boolean expression or the logic functions. It is named after kernel who introduced it in 1953. The K-map allow us to visual minimization of Boolean expressions, especially those with 2, 3, and 4 variables. So, looking at the purpose and the uses of the K-map, K-maps are used in digital logic designed to simplify the complex Boolean expression in a more systematic and visual way than the algebraic manipulation like Boolean expression methods. Then, simplification for K-map leads to the simpler circuit design with the fewer gates and resulting in optimizing and effective digital systems. So these are here the gates are the OR gate, AND gate, and universal gates and the and logic gates which we are using. So we can get a simplified version of the circuit with the use of with the simplification of the K-map. So this is the main purpose of the K-map. Then looking at the K-map structure, so cells, number of cells and adjacent cell. This is the main three concepts where the K-map is drawn and the structure includes. So cells, each cell in a K-map represent a mean term or the product of literals with each variable appears either with 0 or 1. So these are the, if we look in this diagram here, the each box in this one is the represented as each cell. So this is the first zeroth cell, first cell, and this is third cell, this is second cell. So here the number will exchange with the third and 7. So this will continue the sequence 4, 5, and here will be the 6, and this will be our 7. So this is the cells representation, cells how we represent. Then how the number of cells will depend. So how to identify the number of cells. So the number of cells in the K-map is always the power of 2. So it will have always the power of 2, which means the number of variables it will be the power 2, 2 through the power of number of variables. So if we has a variable of 3, then it will be 2 power 3. If we have the variables of 4, then it will be 2 power 4. So here we have the expression the power of 2 corresponding to the number of possible input combinations. So these are the possible input combinations. How many input combinations, either we are giving A or ABC or ABCD or ABCDF, depending on this one. So the input combinations will depend, then the number of cells will depend. So for instance, the K-map for three variables, if we are considering three variables, that is A, B, C, if we are considering these three variables, then it will has a 2 power 3. So 2 power 3 will be 8 cells. So this diagram represents the 8 cells of a K-map. Then if we have the four variables, that is A, B, C, D, if we are considering not only A, B, C, D, if we can consider P, Q, R, S, like that. So if we consider four variables, then it has a 2 power 4, it will lead to a 16 cell. So this is the 16 cell. So here if we look in this diagram, this will have 16 cells. This is the 4 cross 4 matrix now. So like a 4 cross 4 matrix, here we have 16 cells. So 1 2 3 4 5 6 7 8 9 10 11 12 and 13 14 15 16. So this is the 4 cells. Then the concept of adjacent cell, adjacent cell in the K map, that is the adjacent differ only by 2 bits in the binary representation. So the cells which are adjacent, so if here if we zoom it and if we have a look in this, so here we are representing the 0 0 0 1 1 0 1 1 1 1 0. So these are the adjacent cells, and we are naming with number digital binary digits. So here 0 0, then it is incremented by 1, so it will up to, it will become a 0 1, then it is incremented by 1, and it will become 1 1, then we are adding up 1 or incrementing by 1, so it will give up 1 0. So this is the adjacent cells increment, so they are differing by 1 bit only in the binary representation, which is based on the gray code ordering. So this adjacency is crucial in combining the mean term for simplification. Mean term, where this is very useful in combining the grouping while grouping the mean term and the max term for specific simplification. And then looking at these steps to simplification. Next slide. Yeah. Steps to simplify the Boolean expression using K-map. So the question will be like this. Here we have representing the, here we have given the question with find max term. We are looking for the max term for 0, 6, 7, 8, 12, 13, 14, 15. This will be our question. So how to solve this K-map using this expression? We are finding the max term, not mean term. So this is of max term. Max term means we are using a logical OR gate, sorry, AND gate. So plus will be the, sorry, it's OR gate. We are using the plus as a symbol. So it we are representing these max term with zeros. So mean term will be represented by 1 and the max term will be represented by 0. So first, filling up the K map, populate the cells with either 0 for the max term, whether the functions evaluated to 1. So if a function is evaluated to 0, it must be 0, sorry, it has 1, or 1 for the mean term. So if we are about to find the mean term values, means we are giving the input values are the, in the K map we are representing zeros as 1 1 1. So here we are about to find with the max term, so obviously we are putting the inputs as 0 0 0. Then we have if we look, yeah, the question is 6 7 8 12 13 14 15. So in this K map, if we have a look, means so this is the zeroth cell, so zeroth cell we have representing the 0 and the number is 6, so this is our sixth cell. So we are representing this as a 0 and the 7, and this is our 8. So this is the eighth cell. Then we have 12, 13, then this is our 14, and this is the 15th cell. So these are the cells we are representing, and we are representing with zeros. Then what's our next step? Writing the simplified expression before the sorry, identifying the groups. Now we had filled, we are done with the filling of K map. Next we are with identifying the groups. Adjust group the adjacent zeros with the rectangular of size power of 2, 2 of 1 2 3 8. So powers of 1 2 3 8. So we have to group in this order: 2 power 1, so 2 power 1 will be 2 only, then 2 power 2 4. You can group the 4 cells, and 2 power 4 like we 16, so we can group only 16. 2 power 8 32, 32 we have to group only 32 blocks like this. So here we have only 4 variables A B C D, so we have only 16 cells K map. So we are limited up to 8, sorry, 4, 2 power 4, that is the 16 cells. So we can group of 8 16 terms. Okay, then each group should contain as many adjacent ones or zeros as possible, and the group may overlap. So now now the identity we have to group the terms. So first group will be we have to identify this as a first group. So if we consider this K map, so if we divide the K map like for year, so if we divide these two cells as one, these two cells one, if we consider this whole as a paper, then this is our center axis. So if we consider, if we fold along the central axis like this, if we fold along the central axis, it will overlap. So this term will overlap over this term. So this will be, we group it as a dual. So you can group it as a dual. So 2 power 1, so you can group it as a dual. So 2 power 1 we are looking. Next, is it possible to make a possibility of 4, that is by not 2, we have done with binary, sorry, dual. Next we have quad, so we can group up quad numbers. So 2 power 2 is a 4, so we can group with quad. So we are next grouping the quad, so like this. So we have the adjacent cells as 0 0 0, or these are adjacent. So we are considering this as a group, and we are with a representing a grouping is as a quadrant, so quad. So then we can also group this like this group also. So we can't group the diagonally, we can group only horizontally or vertically. So we are grouping this one, and we are representing as a third group. So this is the identification of the groups and grouping of the terms. Then write the simplified expression. So writing of the simplified expression for the group terms is the next step. For each group, derive the simplified product term known as the prime implicant. So we are representing the prime implicant. So 0, if we have 0 and 1, they are called as a prime implicant. If we are representing x where the term is not defined, or the where the term we don't know which is it, or x is this max term or the mean term. So by that time we call that condition as the don't care condition. So we are representing that condition with x. If we don't know it is to be represented with 0 or 1, then we are going to represent with x, then that condition will be called as the don't care condition. So here we don't have that don't care condition, so we have all the prime implicants. So we have grouped the prime implicants. Now we have to simplify the prime implicants. Yeah, now first group is this one. So if the first group is cell a plus b and c plus d, where and also a bar d a bar b and c plus d. So we are considering these two. So we can group this a plus b and a bar plus b. So what is the common term is here? B. So b is the common term. We are writing the b. We are a plus a bar will rise up to a 1, so it will end up to 1, so we are not considering a plus a. Then we b is the common term, so we are representing the b. Then this term for this row, this is the c plus d. We can't simplify anymore, so we are writing b plus c plus d. This is the group 1 simplification. Then we have the group 1, a group of this one. So if we consider, so this will a bar plus b bar. If we have only this one, we can't simplify anymore, so we are writing a bar plus b bar. Then we have to consider all these expressions as a plus d, c plus d, c plus d bar, c bar plus d bar, then c bar d. So we have to consider all these expressions. So when we simplify this all these entire expression with this one simplify this expression, so we will end up with 0, sorry, we will end up with 1. So we are multiplying this 1 with, so a plus a bar plus d bar will be there. We can simplify this using the De Morgan's theorem, so we will end up with 1. So this is the simplified version of that is simplification of the group 2. Then we have group 3. Here group 3 is represented a bar a d bar plus a bar b bar. Then we have c bar d bar plus c bar plus d. So this is the representation where the locations of these cells. So when we have a common term, which we have common term is b bar, so we are writing a b bar as the common term. And for these two we have a common term of c bar, so c bar plus d bar will be the common term. Then this is the simplifying the expressions of each group term. Then final boolean expression, then we are comparing the product terms for all groups. Then we are combining the sum terms to a product, so it must be sum terms to the product for the expression to obtain a simplified boolean expression. So when we product up this sum expressions, when we product up, we will end up with this y expression. So the max term for this numbers given is b plus c plus d into a bar plus d into c bar plus d is the expression of the max term. So this is the method of solving the boolean expressions. Then looking at the advantages, simplification. So advantages, simplification. Um, K-map make it easy to simplify the Boolean expression, reducing the number of terms and logic gates retained in the circuit. So you can reduce the number of gates which we are execute in the digital circuit. Then visual representation. So visual nature of the K-map makes the process intellectual and easy to follow, and easy to follow compared to algebraic simplification. So this will be comparably easy compared to algebraic simplification. Then effective for small products. So K-maps are particularly effective for Boolean expressions with a small number of variables. Up to 4 and 5 is the maximum where humans can solve. And then if we consider the 6 terms, it will be of a more number of cells. Then it will be of 64 cells where it's not possible to solve easily. So it's only effective for small products. Then group minimization, it helps to clearly identify the potential reduction in logical expression for performing the group of max terms, mean terms. Then we have the disadvantages. Here disadvantages: limited scalability for Boolean expression with more than 5 and 6 variables. More than up to 4 we can manage. Then with 5 and 6 variables, that is a b c d e, if we consider 5 variables, the K-map become difficult to handle. The number of cells grows exponentially. With the increase in the number exponential power, 2 power 5, 2 power 6, with the increase in the power, the numbers of cells will be increases. So there will be growth exponentially with the number of variables. So making it impractical for large functions. So then manual errors. The group of mean terms and the simplification process is manual. So we have to do this simplification, or we can use K-map only for manual use. We can't upload it for the system use, or we can't run in the system. So it is only for the manual use only, which increases the chances of human error. Where the you see, obviously if the man is doing this, there will be chances for human error, and if the number of cells are increasing, then it will be 100%, there will be a bit of human error also. So especially for the complex maps. So this is the main disadvantages. Then complex with the don't care conditions. Yeah, I have told that don't care conditions, so we are representing with x na, so that is the don't care condition. While K-map can handle don't care conditions, the process cannot become the process can become a tricky and less intensive, less intellectual. So this is the main drawback and ineffective for computers. K-maps are primarily manual technique and are not well suited for automated simplification in a large scale designs where software algorithms so are used, software algorithms are used. I have told you na, the computers cannot using computers we can't solve the this one. So looking at the conclusion, K-map is a powerful tool for simplification boolean expression in digital logic designs, but they are best suited for functions with related small number of only for small number of variables, where while they offer a clear and visual way to minimize logics, they become improved for large functions where automated methods are performed. So this is for our presentation. So thank you one and all for watching our video. Please do subscribe our channel for such more informative videos. Thank you.